What's up, ES117? I'm Karam,
And I'm Luca Bozo.
and this is our project about climate change and the oceans.
We've interviewed two experts on the impacts of climate change in our oceans, and they have presented us with some main factors of what's going on today. This is especially a relevant topic to me as a coastal resident and a surfer, because climate change has been impacting our oceans and the effects are panning out as we speak.
For my expert interview, I was able to get an interview with Gabriel Rodriguez of the city of San Diego. His current employment status is a marine biologist for the city of San Diego, and he's been working in this field for quite a few years, since 2015. And he graduated with his PhD from UCSB, Ren, and he also went to Cal State Monterey for his undergraduate, along with his master's degree.
My expert interviewee is a family friend, Seabury Nakbar. She works for the NOAA as the coordinator of the Bay Watershed Education and Training Program, aka BWET. She has a background with Moss Landing Marine Labs and has her master's degree in marine biology. My hometown, Monterey Bay, is currently suffering from some of the impacts of climate change. As carbon becomes more concentrated in our atmosphere, ocean acidification is becoming more and more of a problem. This occurs when CO2 enters the water and reacts with carbonate ions to create carbonic acid. Carbonate is a key component of the development of shells on shellfish and the growth of coral. Seabury Nakbar has identified ocean acidification as a large impact on Monterey Bay.
The one impact that Monterey Bay has probably to deal with the most is ocean acidification. And we're actually identified as one of the hot spots for a huge increase in ocean acidification, which means that the carbon cycle in Monterey Bay gets thrown off.
In addition to ocean acidification, CO2 can act as a catalyst for algal blooms, which is another problem facing Monterey Bay. This has been a problem as algal blooms cause eutrophication as well as disease to marine life. One negative effect of prolonged algal blooms that Monterey Bay has been facing has been large die-offs of sea lions. This is due to a certain type of algae that produces domoic acid, which acts as a neurotoxin to sea lions, causing them to act more aggressive and eventually die. Seabury explains that algal blooms are a natural occurrence, but have lasted longer in recent years.
We do have natural algal blooms in Monterey Bay that are just, they're seasonal, they happen, but what we're seeing now, and they're attributing some of it to these warmer water events that we have and climate change, is kind of a prolonged event. So where you had a harmful algal bloom that was maybe a couple months, it now lasts a lot longer. It starts earlier and it ends later. I just walked Monterey Bay, and I was walking on the beach the whole way, and the number of dead sea lions was just amazing.
Climate change is causing severe storms. This has become a problem for Monterey Bay because storms have been causing flooding events, giving rise to nutrient runoff and sedimentation. In a nutshell, storms are causing eutrophication and habitat loss in our oceans and on our beaches.
Yeah. So these rain events, it's nutrient offloading, and then also sedimentation.
Oh, yeah.
That also really messes up the ecosystems too, because that can smother, any kind of ecosystem on the ground, any species that is a ground dweller, a permanent ground dweller.
Storms out at sea cause large waves. The intensity of these storms is increasing as the Earth continues to warm. The intensity of swells has cost countless lives and infrastructure along the California coast. Large waves create dangerous conditions, especially for tourists. Erosion is a product of large swells, something that we are seeing in Isla Vista. Economies are suffering as visitation begins to dwindle and resources are diverted towards first responders and infrastructure.
Warmer temperatures also lead to more wave events, like prolonged wind events. I mean, when you think about, because climate change, it's more than just an increase in temperature. It's completely putting off balance and off kilter our whole oceanographic and atmospheric currents. I'm sure most counties and cities are looking at is the economic impacts of climate change. I mean, how this is just going to devastate some communities because all of a sudden they can't grow what they used to grow, or they can't fish because the species that they were fishing is gone, or their beaches are gone.
Yeah.
Imagine a beach just disappeared.
Pollution is often overlooked considering the big picture of climate change. However, microplastics are being researched and identified as a major issue regarding marine life. Seabury explains how microplastics often enter the ocean through rivers and tributaries. Microplastics can make their way up trophic levels through biomagnification and even carry toxins through chemical bonds. This can affect humans as we consume seafood. According to Stanford Medicine, microplastics can potentially cause cancer, heart attacks, reproductive harms, and a host of other problems.
So this office is doing a microplastic study right now. They received, I want to say, close to 200,000 to do a study where they're sampling water in rivers, at river mouths, and then offshore in the ocean off of where the river outflow is. The research that they've seen so far, every single sample that we've collected from river, beach, and ocean have had microplastics in it. Every single sample. Animals, that it obviously clogs up their system, and so they feel like they're full, but they're not full on food. And they're also finding that these microplastics attract heavy metals and toxins.
Oh, no way.
Alrighty, to pan back out to my interview with Gabriel Rodriguez, I learned a lot of very, very valuable information in a very different lens of how people actually perceive ocean acidification and how audiences actually take in the information and how we can actually make a change. So to start things off, I'm looking at my notes because I took a lot of notes, and really when it comes down to measuring ocean acidification, it's an array of pH, particles of CO2 within the water, alkalinity, and dissolved inorganic carbon within the water. So all of these factors affect the actual species that are living in the oceans. Obviously, we all know that ocean acidification has a huge toll on calcifiers in many shell organisms. It can break down their shells. It can, lead to very numerous diseases for these species, and some species can go extinct due to this factor. For the city of San Diego specifically, there's a ton of moorings and a ton of vessels. There's actually only 2 vessels, and there's a ton of moorings. These moorings are essentially buoys that have a ton of sensors on them. And Gabriel was reiterating what they were to me, because I never even knew that this was an actual factor of the city of San Diego. So these specific monitors, they've taken all these variables. They even taken variables like whether the water is actually safe to swim in for the general public of the city. And when it comes down to just the general basis of why San Diego County has a marine biologist program, it's because of outfall. There is one sewage plant throughout the whole city of San Diego. Every single bit of sewage gets pumped to this one specific wastewater treatment center. And in this wastewater treatment center, it treats all this poop, and what essentially happens is it gets dumped into the ocean. 175 million gallons per day is being pumped into the ocean. Obviously, there's a lot of parameters that come in between this. So something I really want to point out is Gabriel also told me about the infrastructure of our sewage systems. So this outfall that we're talking about, that the city of San Diego has the marine biologist program for, it measures outfall of specific, substances within the water that could cause and spread disease. There's a ton of pump stations that pump and pressurize shit. Sorry, excuse my French, but essentially it pressurizes the poop. And what ends up happening, there's 44 pump stations in the city of San Diego.
it all transfers into Point Loma, and in Point Loma, there's a wastewater facility hidden behind 2 mountains. You would never even know it's there. But that's the reason that San Diego County even has this program. When we're relating it to ocean acidification, there is so many different monitors that help us actually see what's going on in the water and the industries that are causing issues with ocean acidification in specific regions. So looking back at my notes, it's very important to see local changes throughout our ocean, not values, but the actual numerical data. So again, going a little backwards, it's more about audience, obviously, but there is the chemistry behind it, and there is the actual active monitoring that is taking place to help with studies. And Gabriel did a really good job of teaching me how, these, systems work, but at the same time, it's very complicated for the average consumer to actually learn about. And obviously we're, UCSB students studying environmental studies, so we have a little more background than others. And I emphasize this, please just make sure to actually study your audience. That's the most important part, because if we want to make a change, we need to be good teachers. We need to make them interested in the topic. We can't just give them the chemistry and expect that they understand it and care about it. So really, study your audience, and the oceans will get better as time, goes by, as long as we're doing our part.
Alrighty folks, and just to add on, just remember to keep your hopes up. Ocean acidification can be a very depressing topic, but as long as we study our audiences and share the education and information we have shared with you guys, we can have a positive outcome.
Thank you so much for watching our video about climate change's impacts on the ocean. We hope you enjoyed it, and we hope that you inform others in the future about what we're doing wrong and what we could be doing right.
Somewhere beyond the sea,